Hello friends, and welcome to my new video in the series DS and Algo for coding interviews. The problem that we'll be covering today is binary tree right side view. Okay, so if we are given a binary tree, we have to return its right side view. Okay, let's understand this problem with the help of an example. So suppose you are given this tree as an input, okay, and we have to return its right side view. You will basically see that the nodes which are visible from the right side are 5, 8, 6. Okay, because this 8 does not have a right child, so the 6 will be visible from the right, and then 3, 9 and 2. Okay, so we have to return a list which contains these elements 5, 8, 6, 3, 9 and 2. Okay, the approach that we'll be taking up for solving this problem is, first we'll perform breadth first search on the tree. So breadth first search will help us in identifying the nodes at a particular level in the tree. Okay, and then out of those nodes at a particular level, we'll try to identify the rightmost node. Okay, in my approach, I'll basically use null to separate the nodes at different levels. Okay, so now if you combine these two steps together, okay, first we perform BFS and then we try to find out the rightmost node at a particular level. Okay, let me explain the use of this null delimiter here. So if we parse the nodes at a particular level in the tree from right to left, okay, and we know that this level is separated from the other levels with the null delimiter. So we can easily know which is the rightmost node. So rightmost node will always be the next node to this null delimiter. So whenever you encounter the null delimiter, you will always know that the next node from this null delimiter will always be the rightmost node because we are traveling from right to left at a particular level. Now let's jump onto the code, and while coding I'll explain to you each and every step in details. The main job here is to implement this right side view method. It takes the root of the tree as an input argument and it returns the right side view of the tree. Okay, now let's consider this example. So our tree in this example looks something like this: 1, and then its left node is 2 and 3, and then there for 2 the left node is null, the left child is null, and the right child is 5. For 3 the left child is again null and the right child is 4. Okay, so now if we parse the tree level by level, okay, so first we'll parse the first level. Some people call it at the 0th level, but I'll be calling it the first level. Okay, so this first level contains the root node, the second level it contains 2 and 3, and the third level it contains 5 and 4. So remember friends, we have to first add the rightmost node to our queue. Okay, so we'll be going right to left. Okay, so at every level we'll be starting with the rightmost node and we'll be going towards the leftmost node. So after 1 we'll be adding 3 and then 2. Okay, and in the last level also we'll be first adding 4 and then we'll be adding 5. Okay, now as I have already shown you in the slides that we'll be using null as the delimiter. So for the first level the queue will contain 1 and null. Okay, so we'll first add 1, then we'll add null, which means that this level has finished. Okay, for the second level, as we traverse from right to left, right, so we'll add 3, 2 and null, which will indicate that even this level has finished. Okay, and for the last level we'll basically add 4 and then 5 and null, which will indicate that this level has also finished. Okay, now let's start coding. First I'll check for the edge case. So basically if the root is null, I just return an empty list. Okay, now I will basically create a queue which will contain tree node. Okay, so I'll name it as BFS queue. Okay, in Java the linked list class, it implements the queue interface so you can use it. Okay, so for the first level I'll be adding root and null. So I'll be adding root and I'll be adding null. But remember friends, how we'll find out that this is the rightmost node at a particular level? So if we have encountered null as the previous node, we always know that the next node is the rightmost node. Okay, so if we encounter null here, okay, the next node will always be the rightmost node of the next level. Okay, and if we have encountered this null, then we know the next node 4 is the rightmost node of the next level. Okay, now I'll basically iterate over this q I need one more node for pointing to the previous node. Okay, so tree node, I'll name it as previous because it will keep track of the previous values. Okay, now I'll basically take a tree node out of this BFS queue. Okay, the first case is if this node is equal to null, okay, and previous node is also equal to null, then we basically return our result list. Okay, so I have not created a result list, but let me create one. So okay, so in this case you will simply return the result. This condition will arise when we are done traversing the tree, when we have traversed its each and every node. Okay, so basically if the current node is null and the previous node is also null, okay, then this basically means that we have traversed all the node in the tree. Okay, and then we can return the result. Now the other condition is if node is equal to null. Okay, in this case what we'll do is, in this case we'll basically add null to our BFS queue. Okay, so try to understand this with this example. Okay, so at the first level you will encounter null, okay, when you have already added the child of this node into the queue. Okay, so if you encounter null, this means that this level has already been traversed. Okay, so now the nodes in the queue are the nodes from the next level, and once you encounter this null, that means that even the next level has been completely traversed. Okay, so you will add null at the end of it. Okay, and this is what this represents. So if you have reached this null, right, so you have already added the left and right child of this 3 into the queue, and you have already added the left and right child of this node into the queue. Okay, so when you reach this null, it means that even the next level is completely passed, and you just close that level with the null value, which I'm doing here. Okay, now if this node is not equal to null, okay, then if the previous is equal to null, because if the current node is not null, okay, if this current node is not null but the previous was null, that means that right now we have the rightmost node of that level. Okay, so if the previous was null but the current node is not null, that means that after traversing this we are on the next node now, which is 3, and it's the rightmost node. Okay, so we'll be adding the node to the result. Okay, similarly if you are on this null, so if this is the previous value, okay, so that means you are currently on 4 and this is the rightmost node at that particular level. Okay, so I'll be adding it to my result. Okay, now if previous is equal to null, so we add this root to our result because this is the rightmost node of that level. Okay, and then basically if oh, sorry, this should be node, not root. Okay, and the other thing is if node dot right is not equal to null, we add it to the result. We don't add it to the result, we add it to the queue. Okay, so we basically say node dot right because we are traveling from the right to left. Okay, as I said here. Okay, from right to left. So first we add one, and then we add its right child first, and then we add its left child. Similarly, for the next level, we add the right child first, and then we add the left if it is not null. Okay, so first the 4 will come, and then this 5 will come. Okay, so we are traveling from right to left. Okay, so we are traveling from right to left, and so now let me perform the similar check for the left node. If it is not equal to null, we add it to okay. Now this part is done, so we have added the right and the left node. Now let me assign this current node to previous. Okay, yeah friend, so I think we are pretty much done with the code. Okay, and as the last statement, I should actually return the result. So this is the complete solution of this problem. It is one of the most commonly asked problem when it comes to coding interviews. I'll check in this code into my GitHub repository and will provide a link to my GitHub repository in the description section of this video. I'll also provide link to the coding portal where we can solve this problem. If you like the content of this video, please give me a big thumbs up and please subscribe to my channel. It gives me a lot of confidence when I see new users subscribing my channel. I'll soon come up with a new video on problems frequently asked in coding interviews. Till then, keep practicing and keep learning. Goodbye for now.